And I think you'll be able to hear my voice if you're at home. You're just trying to follow this, but hopefully this will pick up. I got a headset with a microphone. I guess I'll try and see that. But, ready? For gamma, what we're doing today, right? A completely randomized design. We're going to try and collect data. What we have to do is say, we want to minimize bias, right? So if we want to minimize bias, bias occurs when the sample statistic does not map, give me some mocking does not map onto the population parameter. That's bias. We want to minimize that. So we need to have a sample that represents the population. And one way to do that is completely randomized design. But, ready? We might end up with something that looks like this. If it's completely randomized design, did I lose that already? I'm going to get this over. I thought I had this document, and I didn't. I think this is it. Yeah, so this is the picture that was on the 4.1 beta lesson, which I told you came out of a different textbook. This simple random sampling goes with a completely randomized design. Simple random sample refers to an observation. An observation is different than an experiment. How are they different? Oh, I'm accountable for that. See, I'm accountable for some things already, which is the definition of R squared, which is what? Correlation coefficient is R. What is the definition of R squared? We told you so far there's three things you're expected to know. It is the proportion of change in the output that can be attributed to change in the input. And you're also responsible so far for bias. And bias is when the sample statistic does not map onto the population parameter. The next thing you're accountable for is the difference between an observation and experiment. In an observation, the participant chooses the treatment. So the example in the book was looking at children who were at daycare through age 4.5 and giving them some score on their behavior and cooperation, and comparing that to children who were fortunate enough to have their parents at home with them and they didn't have to go to daycare. But the point is, you don't take children away from their parents and say, we're putting your child in daycare to participate in this experiment. They just looked at people who already made that decision. That's an observation. An experiment, the treatment is imposed on the participants. So this is a simple random sample. It goes with an observation. But remember we stratified this. We built by class you're in. We said like who are the freshmen, 10th graders, 11th graders, 12th graders. Then put people in, take the whole advisory. It's easier to collect data that. Pick an advisory at random. This is now going here. That picture we just showed you, it's on 4.1 beta, goes with an observation. If we have an experiment, it's called blocking. You have to keep this stuff straight. So like I went to these documents and made these distinctions here. For me talking doesn't mean that you process. You need to say, okay, well that goes with this, that goes with that. Okay, can I keep this straight? Blocking an experiment would be matched pairs, repeated measurement. And we have this activity, this isn't in your book, PoS activity. So the people at home are going to try and follow what's going on here. But we're kind of compromising the activity. And you can You can follow the directions we're doing it, but you're not going to have somebody be paired up, right? So we're going to have an experiment. And in order to do the experiment, we need a pre-score. Okay? So the pre-score is going to be your resting heart rate. Now you're going to have to write this down. People, oh, I don't remember which one it is. Right, huh? Right. You're going to take your pulse. I will tell you when to begin. Ready? Your fingers. You can't use your thumb. Your thumb has no pulse. Your fingers on your wrist or your throat. And I'm going to tell you when to begin counting on your pulse. Begin. Stop. You take that number and multiply it by 4. That is your pre-score. Everybody in the room has a pre-score. We good? And now we're going to go here. I'm going to number the children in the room. 1, 2, 3, 4, 5, 6, 7, 8. 8, 7, 6, 5, 4, 3, 2, 1. Good? We're going to pick 4 people. And they are getting the treatment. And those people are 1, 3, 4, 7. Okay? 1, 3, 4, 7. You good? The treatment is we're going to measure your pulse rate standing. You know. We're going to repeat this. All right, so you got to find your pulse. Yeah. Take that number, you multiply it by 4. Okay? So far, we have this. We're going to go, you're going to tell us your resting heart rate. Sitting heart rate. Gary. Hey, Joe. Joey. Andrew. Breeze. Have soda one? No. Mallory.
74.
Jordan.
74.
Brian.
80.
Okay, the people that had the treatment, give me their treatment score. So that's 1, Gary.
72.
Then we go to Joey.
96.
Fox at 68. Jordan.
81.
Let's get a 1. And then multiply by 4. We'll say 8. Good? So now what? We're looking at this thing, and everybody that got the treatment, their heart rate went up. You good? randomized design. We pick people randomly out of the whole group. It was a small group, it was like 8 people. We picked 4 of them to do this. We got it? We're moving next to blocking now. And blocking goes to the stratification from the observation. It would look like this. Matched pair. So this would be the matched pair. And then, at least in the past, you would do this. You get up, stand up in front of the room, and you would pair up with somebody. So the people to be paired up would be Grace and Brian. They had the highest number. Yes? Yeah. Well, we flip a coin between Brian and Joe. You see, because they're both equal. Good? Then, next one's 74. Right? 68, 62, 72, 70. They would be matched pairs because it was you were matched with your pre-score. So you literally would have stood in front of the room in order. Lowest pulse rate in the front, highest pulse rate around the room. And then count on 1, 2, 1, 2, 1, 2, 1. No. 1, 1, 2, 2, 3, 3, 4. So that's your group. And then what would happen is we would flip a coin, we would do something to randomly assign a treatment. We're not talking about pulse rates. I mean, that's pretty easy friendly. But if we had something where we were trying, like, I don't know, how about the COVID vaccine? If we were trying, like, you read in the paper about these, like I read the headline, I read the article. 1,000 people volunteered to participate to get infected with COVID. Make sense? Do they understand this? If they participate in the trial, half of them aren't getting the vaccine. They're taking on being infected. That's a noble thing. Half of them are getting a needle with nothing in it. Because they have to be measured against the people that got the vaccine. And you have to sign off on this. I mean, it's not like somebody get a needle. You say, you understand what you're getting into. So only half the participants in the trial are going to get the actual vaccine. People still get a needle. They think they might have it. They don't know. It's blind. The participant doesn't know whether they got the treatment or not. But what we could do to stratify this, ready? Instead of a completely randomized design, we could match you up with someone who had a similar pre-score. And one of you would get their resting heart rate, and one would get the treatment, and we would compare. So who's paired up? Well, ready? You paired up all the people, didn't you? Right? You did both. That's not going to help. We would get the treatment score from your part and see if the increase, we didn't get the statistically significant, but is there an increase and can we say it's significant by standing up? The other way of blocking is repeated measure. And a repeated measure is this. These are repeated measures. You're compared to yourself. Oh, well, if I'm comparing to myself, I'm always want to do that. Because that's, I can see, like, right? But you can't always do that. There are circumstances where you can't compare to yourself. So this is preferable repeated measures, but matched pairs available. You'll see, like, if you read any journals or anything, a lot of medical studies are done with identical twins. They're the matched pair. They're the same DNA. That's why they use a identical twin. It's the statistical reason they do it, it's a matched pair. Or you could have completely randomized design. Now, here's the point. You have to make sense of this box. The point of blocking, the point of using a A matched pair, a repeated measure, is you want to minimize the within treatment variability. Within, inside, what exists, so that you can better measure the between treatment variability. What we're trying to measure is how much effect does standing up have on your pulse rate. But in order to do that, you have to minimize this. This is within treatment. Look at these pre-scores. They went from a low of 62 to a high of 84. Well, that's a pretty big range there. That's within treatment. So if somebody like here got matched with somebody there, it might seem like the treatment had more of effect than if somebody who had a high pre-score to begin with got matched with someone. Make sense? Sorry about this. It's really much more fun when you can literally get out and move around the room, take your pulse, and then compare it to somebody else, but it just wasn't happening. So, what we're going to do is you're going to go to 2 questions. Everybody at home is doing the same thing. All right, so we're going to look at these 2 questions, see if this makes sense to you. So 71 was about the farm. Well, it's not like this is that complicated. Ready? I'm saying you divide the trees into small, medium, and large. You take the 10 smallest trees. Just like we said, the people with the lowest resting heart rate would be, instead of paired up, we'd have a group of 10. So that each of the fertilizers was distributed among small, medium, and large trees. Okay? Like larger trees would be expected to produce more fruit. I was thinking of smaller trees growing more, but they're talking about the fruit production. We want to be sure that each of these fertilizers gets an equal chance to be with the larger trees. For the doctor and the nurse practitioner, the block is the illness. The treatment is whether you got the nurse or the doctor. Okay? Well, blocking helps to reduce confounding based on the illness. Like maybe by chance alone, the nurse practitioners got more of the more challenging patients. Then it would look like they didn't do as well. Okay? So when you think about this situation, like we can refer back, even though we didn't get to participate in the pulse activity, you can refer back to it because it helps you make sense of this. If you were lined up in front of the room in order of your resting heart rate, and then you say, ready? First pair, 1, 1, count, 2, 2, 3, 3, 4, 4, 5, 5. When you went through the room, you would have a matched pair based on your pre-score, which was your resting heart rate. Then the repeated measure was you with yourself. Okay? So we'll see how this video turned out.